All right, now we're solving systems of equations by graphing with me, Mr. Hain. And our essential question for this video is, how does solving systems of equations by graphing show exactly what the solution to a system means? So exactly what the solution means. So there's a very specific reason that we call a solution to a system of equations a solution to that specific system. All right, so I'm stalling to give you time to write the essential question, but pause the video if you need to write that essential question. I'll be here when you get back. Let's dive right in. Okay, so there's a ton of stuff here. On your notes, if you're following along at home with me or in the classroom, there is none of this on the graph whatsoever. So let's go step by step on how I got there. Okay, so the system is y equals negative 2x minus 3. Let's deal with that line first. My y-intercept is negative 3. Kaboom. My slope is negative 2, comma 1. Since it's negative, I go down 2 over 1. So you see that the box that has the description for the equation y equals negative 2x minus 3 is the line that falls to the right as we go from left to right here in the coordinate plane. If you haven't done so already, pause the video, draw that graph right now. All right, I'm assuming that you unpause the video because you're done graphing. Let's take a look at the second equation, y equals 2x plus 5. So 5 is my y-intercept, so I'm going to go to the 5 on my y-axis, dot my slope is positive 2. Now that takes me straight off the graph, so I'm actually going to go double negative because two negatives make a positive. So I'm going to go down 2 over 1, and you see that I have that point right here on that line. So that point is at negative 1 comma 3. And if I connect those 2 points together, just like the dialog box says, I've got y equals 2x plus 5. Cool, and that is the line that is rising from left to right in the coordinate plane. Awesome. What does that mean? All that means is that when I graph these two lines with a ruler, then I see that they should intersect right here in coordinate 2. And I have negative 2 comma 1 as their intersection point. This is where it becomes extremely important to understand exactly what the solution to a system of equations means. This solution to a system of equations is exactly where the two lines intersect. And here on this graph, we see it happens right where my mouse is circling. In quadrant 2, at the coordinate point, negative 2 comma 1. I'm going to leave my mouse right over that point. It's probably going to disappear while I'm talking. The point is, the solution to a system of equations is exactly where those two lines intersect on the coordinate plane. The solution to a system of equations is exactly where the two lines intersect in the coordinate plane. All right, let's take a look at some other examples. All right, now let's work it out. Let's take a look at our first equation. Y equals negative 7 halves x minus 3. So the first part that I'm going to graph is my y-intercept, which is negative 3. Kaboom! You see that red dot appear on the y-axis at the point negative 3. Go ahead and graph that point. Now we're going to use our slope, which is negative 7 over 2. That would take me directly off the graph. So I'm actually, instead of running to the right, I'm going to run to the left. So you're going to see me go up 7 over 2 right there. Now I'm going to count it out with my mouse. Let's go. Oh, 1, 2, 3, 4, 5, 6, 7 up. And then since it's negative, I go to the left 2. And when I connect those two dots, you see that my line goes, the right side of my line points down, which means I have a negative slope. Awesome. My orange line for the equation, y equals negative 7 halves x minus 3, has been graphed. Okay, so the first point was negative 3 on the y-axis, and the second point was negative 2 comma 4. And that's where I connected those two together to get the graph of my first equation. If you need to, pause the video now and make sure that everybody has graphed that second equation. Or if you're at home, you might need some time. to just graph that equation. Pause the video, I'll be here when you get back. Let's take a look at our second equation. Now my second equation, I'm going to graph that in green, is y equals negative 1/2 x plus 3. That's negative 1/2 x plus 3. So my y-intercept is positive 3. So you'll see a blue dot at positive 3 on the y-axis. Then my slope is negative 1/2. So I'm going to go down 1 over 2, which puts me at coordinate 2, 2. Put a second dot right there, and I'm going to connect those dots in green. Okay, and now you see something cool. Those two lines do intersect, and they intersect exactly at the point negative 2, 4. Exactly at the point negative 2, 4. And because we can see that, we know that the solution to this system of equations is negative 2, 4. The solution is where the two lines intersect and the coordinate point where they intersect, negative 2, 4. Go ahead and pause this video and do examples B and C on your notes or a piece of graph paper if you're following along at home. I will be here when you get back. We're back. Let's take a look at some interesting cases. Okay, let's take a look at example D. So I'm going to take the first equation, which I'm going to graph with a blue line. And I see that that equation is y equals negative 2x plus 2. Awesome. So plus 2 or positive 2 is my y-intercept. So you see a green dot at 0, 2. Then my slope is negative 2, which is negative 2 over 1. So from here I'm going to go down from the 2 on the y-axis, I'm going to go down 2 over 1. That puts me at 1, 0. Second green dot, connect the dots. Boom, I have a line in blue. Let's take a look at my second equation, which I'm going to graph in red. That second equation is y equals negative 2x minus 2. So I know that the y-intercept is negative 2, so I've got an orange dot at negative 2. My slope, again, is negative 2, which means it's down 2 over 1. So I'm going to go down 2 over 1. So for the second equation, that places me at coordinate 1, negative 4. For the second dot, cadabra, it's there. I'm going to connect those lines, and guess what? We got a problem. Didn't we just say that the solution to a system of equations is where those lines intersect? If we're looking at the equations, we see that we have negative 2x or negative 2 as the slope for both of them. Guys, if the slope is exactly the same and the y-intercepts are different, that means they're parallel. They'll never intersect. You'll never have a solution. Therefore, the answer to this system of equations is no solution, because the lines will never intersect. Okay, so you might be looking at example E and thinking to yourself, I already know the answer. Great. But the most important part is being also able to graph them. So take a moment, graph those lines in your notes. Pause the video. I'll be here when you get back. Ladies and gentlemen, that is the end. So if you're in my class, write the summary and make sure that your table of contents is updated. And if you're following along at home, and everybody in the classroom, until next time, keep doing the math.